Welcome back to our discussion of derivatives. At the end of the last video, we had arrived at these two different formulas for how to write down the derivative of a function at a point, which is the instantaneous rate of change, the slope of the tangent line. We'll talk about all of that later. But I wanted to add one more way to write this, just in case you were hurting for different ways to write this. Namely, the derivative at a point is really the limit as h goes to 0 of the average rate of change of the function from a to a plus h. So I'm taking a very tiny interval and I'm making that interval smaller and smaller and smaller as h goes to 0 until this interval is approaching just the interval from a to a. So in this video, I want to go ahead and calculate this derivative at a bunch of points. Okay, so here is our first example. So I want to find f prime of 5 if f of x is 3x minus 7. So I need to write down my 2 points that I'm finding the average rate of change between. So it is namely 5 comma something, and it is 5 plus h comma something. What thing is going to go here? Well, it is going to be f of 5, which is 3 times 5 minus 7, which sounds like 8. And then what's going to go here? This is going to be f of 5 plus h, which is 3 times 5 plus h minus 7, which is 15 plus 3h minus 7, which is 8 plus 3h. So I have here, this is point 1. This is point 2. And in order to find this derivative, I want to find the slope between these 2 points, and then take the limit as h goes to 0. So let's find the slope between these 2 points, which is also the average rate of change. All of these words are the same. Which will be the difference in the outputs, so that'll be 8 plus 3h minus 8 divided by 5 plus h minus 5, okay, which I can simplify. That will be 3h divided by h. And that will really just be 3. And so in this case, f prime of 5 is 3. Okay, I want to point out what happened here. What happened here is that I looked at a function whose graph is a line, and then I asked the question, what's the slope of the graph of this line at 5? Okay, and I got the answer that it's 3. Well, 3 is not coincidentally the slope of the graph at every point, because the graph itself is a line. And so, really, if I were to translate this into the fact that I learned, one way to say this is the slope of the graph at x equals 5 is 3. Okay, that's what this f prime of 5 equals 3 is telling me. But again, this is a line, so I should believe that. Okay, let's do another example where the graph of the function we're looking at is not a line. Again, to do this, I want to first write down 2 points. The first point is going to be the point on the graph whose x-coordinate is this input. Okay, so I'll look for if the x-coordinate is minus 2, what's the y-coordinate? It's g of minus 2, which as it happens is minus 2 squared plus 2 times minus 2, which happens to be 0. So that's one of my points. And my other point I want to have as its x-coordinate this input minus 2, but with a plus h. Which is to say I'm imagining I'm looking at a point where the input is just slightly bigger than that input. And then I need to figure out what goes here in this blank, which is going to be g of minus 2 plus h, which is minus 2 plus h squared, plus 2 times minus 2 plus h. So this is going to be 4 minus 4h plus h squared minus 4 plus 2h. If I simplify this, this is now h squared minus 2h, but then the 4 and the minus 4 cancel, so it's just h squared minus 2h. So once I have these 2 points, that point, and that point, I can go ahead and I can find my average rate of change. So my average rate of change, which is also just the slope between these 2 points, so if you would rather just say slope, you can do that too, is h squared minus 2h minus 0 divided by minus 2 plus h minus minus 2, which is just going to be h. So I'm going to factor out an h here from the numerator. Divide by h. I can cancel the h's. So this is going to be h minus 2. That's my average rate of change. Okay. And then I have to remember, what was it I was supposed to do with the average rate of change? I was supposed to take the average rate of change and take the limit as h went to 0. So g prime of minus 2, what is it? It is the limit as h goes to 0 of h minus 2. And that is minus 2. So that is the answer. Okay. So really, this is a 3-step process. The first step is write down your 2 points. Okay. The first point you take as the x-coordinate the input that you're looking for the derivative at. And for the second point, you take as your x-coordinate that same input, but then you add this plus h. And then you make sure you calculate the matching y-coordinates, which you calculate by plugging the x-coordinates into the function. This will leave you with 2 points, and you should do as much simplification as you can, so like we have done here. So then as my step 2, I'm going to calculate the average rate of change of the function between these 2 points. So y-coordinate here minus y-coordinate here, divided by x-coordinate here minus x-coordinate there. And as a tip, because the x-coordinate I told you to put here is always the same as the x-coordinate here, but with a plus h, when I subtract them, I'm always going to get just an h. Then I want to take this average rate of change, and I want to simplify it as much as I can. Now, as a second hint, that simplification should always involve canceling this h eventually. So, I'll make a note. This h, the one that I told you is always there in the denominator, it should always cancel with something. In fact, really, how do you know when you're done simplifying? You know you're done simplifying when you cancel this h. And so here we've gotten this average rate of change. It's h minus 2. And so then as your third step, you're going to take the limit as h goes to 0 of your answer from the previous step. And so in this case, I take the limit as h goes to 0 of h minus 2, and that will give me minus 2. Let's do one more example. So here I'm going to say find k prime of 4 for this k. So I'll note here that for this question, I have said specifically using the limit definition of the derivative. Anytime I say that, I mean I want you to do the derivative exactly how we're doing it in this video right now. Okay. Why do I have to make this caveat? I'm making this caveat because next week we're going to start talking about some shortcuts that you can take for taking these sorts of derivatives. But we don't want to use the shortcuts yet. We want to do it this way for now, and we'll figure out the shortcuts carefully next week. Okay, so again, following our procedure. Step 1, write down the points. So we have 4, comma, and then this is supposed to go ahead and be k of 4, which is 2 times 4 minus 1, so that is 7, times 4 minus 1, that's 1. Okay, so this is 7. So that's our first point. And then our second point is going to be 4, and then we can't forget our plus h. This is the magic sauce that goes into all of this. And so then k of 4 plus h, what is that? That is 2 times 4 plus h minus 1 times 4 plus h minus 3. Okay, and I'm going to try and clear this up as much as I can. So that's 8 plus 2h minus 1 times h plus 1. Okay, this is 2h plus 7 times h plus 1. And I'll go ahead and FOIL this out. This is 2h squared plus 9h plus 7. And so my second point here is 2h squared plus 9h plus 7. And so that's my takeaway from step 1. I have this point and this point. Step 2, I'm going to go ahead and calculate the slope between these two things, which I'm going to label as the a rock, but whatever you like. And so this is going to be 2h squared plus 9h plus 7 minus 7. And remember here it's 4 plus h minus 4, but as I said before, the denominator here always going to be h. Okay, so this is 2h squared plus 9h divided by h. And I can still do a little better because I can simplify the numerator here. And now once I factor that h out, I can cancel that with the h in the denominator. And so this will be 2h plus 9. Again, I know I'm done this step once I'm able to cancel the h's. And then for our third step, we go ahead and calculate the limit as h goes to 0 of this 2h plus 9. And that, because we did all the simplification over here, is just going to be 9. That is k prime of 4. So that is our answer. So it might look like here we sort of got away with doing a really easy limit. Remember, we were sort of used to this whole idea that almost every limit we're ever going to do is going to come out to be 0 over 0, which is going to mean there's going to be all of this algebra and factoring and cancellation involved. And here it looks like we're sort of skating by without having to do any of that. But I want to point out that that's not really what's happening. It's just that we happen to have done that algebra and canceling back over here when we were simplifying this, before we then went ahead and thought about the limit. So really, this thing started out as a 0 over 0 type limit. If you plugged in h equals 0 here, you would get 0 over 0, but because I had us do the simplification here in this step, then it comes out and works out nicely over here. All right, I'm going to wrap up for this video here. In the next video, we're going to talk about how this works for some other kinds of functions. Namely, we're going to talk about how to do this if your function is a fraction, or how to do this if your function involves radicals. But we'll wrap up there for now, and I'll see you next time.